Alrighty, time to have a wonderful morning, doing some very fun math problems. Today I'm going to be working through the first SAT practice exam, stuff I've already covered on this channel, but I'm going to do a quick review before going into my speedrun, which will probably be coming out in the next few days. Hopefully this time I can speedrun an entire section, not just the non-calculator portion or just the calculator portion, which will take a little longer. 50 minutes, or 50 questions is quite a lot. But I'm hoping I can do it all under 30 minutes, but we'll see about that. And let me pull that up. Alrighty. Let's get the right pen color and pen size. That looks good to me. Alright, let's get started. If x minus 1 over 3 is equal to k, and k is equal to 3, what is the value of x? Something easy we can do here is just plug in 3 for k. So we have x minus 1 over 3 is equal to 3. We can multiply this 3 over, and we get x minus 1 is equal to 9. Add the 1 to both sides, and we get x is equal to 10. Our answer is D. For I is equal to square root of negative 1, what is the sum of 7 plus 3i plus negative 8 plus 9i? We just combine the like terms. 7 plus negative 8 is going to be negative 1, and then 3i plus 9i is going to be 12i. So our answer is going to be A. On Saturday afternoon, Armand sent M text message. Let's try that again. On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? Well, you have the number of hours, and then you have the number of messages each of them sent. If Armand sent M text messages each for 5 hours, and it's going to be 5 times n to get the total for him, and if Tyrone sent P text messages each hour for 4 hours, it's going to be 4 times P. So adding those together would be a plus. A and B are wrong. It'd be 5 times M and 4 times P, so our answer is C. Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of the value of 108 in this equation? If we were to draw this out on a graph, it would look something like this. It'd be a negative slope line where the y-intercept is at 108. So we know on day 0, when D is equal to 0, we're going to have 108 phones left. So that's how many phones she has to fix at the starting of each week, and that would be B. 5, nice, a polynomial question. Which of the following is equivalent to the expression above? Let me zoom in a little bit. Okay, there's got to be a better way of dragging this around. I guess not when I'm this far zoomed in. That's a shame. I have to switch to the pan? No. Okay. Anyways, which of the following is equivalent to the expression above? So we're going to be combining this. So we have an x squared y, and we have another x squared y, and we are subtracting. So this becomes a positive, this becomes a negative, and this becomes a positive. So we combine the x squared y's to get 2x squared y. And just looking at this, we know a can't be right. We know which other question has? Okay. Let me restart. Which of the following is equivalent to the expression above? 1 second. There we go. Which of the following is equivalent to the expression above? X squared y minus 3y squared plus 5xy squared minus negative x squared y plus 3xy squared minus 3y squared. Well, let's look at the like terms. We have a x squared y and a negative x squared y. We're subtracting this, so this becomes a positive, this becomes a negative, and this becomes a positive. So we know we're going to have 2x squared y. The only answer that has that is D and C. So we know B and A are wrong, and D and C differ on the y squared. So let's look at the y squared. We have a negative 3y squared, and here a positive 3y squared. So there should not be a y squared term. So D is also wrong. That means C is our correct answer. A pediatrician uses the model above to estimate the height h of a boy in inches in terms of the boy's age, a, in years between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? So we're looking at the increase per year, and we know the age is a. So we know that every year the boy is going to increase by 3 inches. And we know this because of the 3 in front of the a. So the answer is going to be A. Okay, 7 looks like a little bit of a doozy. Very big formula. In the formula above, the formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over 9. The formula above gives the monthly payment M needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? Okay, so we need to solve for P. The first thing we need to do is we need to handle the bottom. So we're going to multiply this to the other side. So we're going to have M times whatever that is equal to the top times P. I'm not going to rewrite that. Okay, so we have 1 plus R over 1,200 to the N, and we have that times N. Well, also the minus 1 times M. So let's look at our possible answers. Okay, D and C do not have that. Yeah, D and C just don't have that, so we know that's wrong. We see that this one has it on top, which makes sense with what we're looking for, while this one has it on bottom. We do not want it on the bottom. We will be dividing by it, but we need the minus 1 on top. Therefore, our answer has to be B. We don't really have to do any other algebra. This minus 1 is our trick to find the solution quickly. If A over B is equal to 2, what is the value of 4B over A? Well, if A over B is equal to 2, then A is equal to 2 times B. That means 4B is equal to, well, we know 2B is equal to A, so 2 times 2B is 4B, and that is just 2A. So we have 2A over A, and that is 2, because the A's cancel out. How nice. What is the solution xy to the system of equations above? So there's multiple ways of solving a systems of equation. You can either do substitution, which is my least favorite method, or you can try elimination. Here we do have a minus x term, so we can try adding both equations together and getting rid of the x. So let's do that. Let's multiply the top and bottom of, well, in this case, let's just multiply the bottom by 3, and that gives us 6y minus 3x is equal to negative 19 times 3, what's that, negative 57? These 3x's subtract when you add them together, so it just becomes 0, and then you get 6y plus 4y, it's 10y. Adding the negative 23 to the negative 57 gives us negative 80. So we have y is equal to negative 8. The only one that has that is b. We don't even have to solve for x. For the function g defined above, a is a constant and g of 4 is 8. What is the value of g of negative 4? If we look at this equation, we see we have ax squared plus 24. If we have a 4 squared plus 24, well, we notice the 4 squared is going to be 16, but also negative 4 squared is the same thing. These are equivalent. So really, we're just plugging in a value into g that gives us the same answer, because g of 4 is equal to g of negative 4 when we plug it into x. So our answer is still going to be 8. We don't even have to try to solve for a here. In the equations above, b and c represent the price per pound in dollars of beef and chicken, respectively, X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? Just looking at this equation, I find it kind of funny that if you were to take like 10 weeks or like a whole year, then This beef and chicken would be very expensive. I get it. I get that it's not supposed to be realistic, but after a whole year, you'd be paying like $21 per pound of chicken? That is crazy. This is a great price to begin with. Wait, hold on. $1.75 for a pound of chicken? Huh. I wish we had that. Sadly, we do not. Anyways, in order to find this, we need to set both of the equations equal to each other because we're trying to find when they were equal, and we can do that by solving for the x. So we have 2.35 plus 0.25 x is equal to, I'm going to write it underneath because I used very big numbers. I wrote it out super huge. So this is equal. We're going to subtract this and this, and that gives us, I think, 0.6. Then we're going to subtract the 0.25 over, and that's going to give us, well, this should be equal, is equal to 0.15x. Okay, yeah, that makes sense. So then we have x is equal to 4. So after 4 weeks, they were equal. However, what we're looking for is the price when they were equal for beef. So that we need to plug in 4 back into the b. So b is equal to 2.35. Actually, we could plug it into either because it's when they were equal, but it doesn't matter. 0.25 times 4. This becomes 1, so it's 3.35. A line in the xy plane passes through the origin and has a slope of 1/7. Which of the following points lie on the line? If it passes through the origin, the y-intercept is going to be, it's going to be 0, 0, and so will the x-intercept. So A is wrong. That can't possibly be on the line. If it has a slope of 1/7, that means for it to increase by 1 on the y-axis, it would have to increase x by 7. This has a slope of 1x, or just 1. This one is the opposite. This has a slope of 7x, or just 7. I shouldn't be saying 7x, my bad. It has a slope of 7, because in 1x it increased by 7. For d we have 14, 2, which means after 2 to the right on x, we increased by 14, which is 14/2 is equal to 1. This is the correct answer, D. It has a slope of 1/7. If x is greater than 3, which of the following is equivalent to 1 over these fractions, which I will not repeat? The first thing we should do is we should combine the bottom, or the denominator. We have 1 over x plus 2 plus 1 over x plus 3. We can do this by changing their denominators. So we do that by multiplying x plus 3 over and x plus 2 over. So we have x plus 3 plus x plus 2 over x squared plus 5x plus 6, because we're multiplying the denominators. And if we look at what that would give us, it'd be 1 over this, which is the same thing as saying 1 times the reciprocal, x squared plus 5x plus 6, over, combine the top, we get 2x plus 5. This goes away, and we get our answer is B. If 3x minus y is equal to 12, what is the value of 8 to the x over 2 to the y? This is a problem that I've come across before, and I spent some time discussing how to solve this exponents problem. So let's take a quick look at how to do that. 8 to the x over 2 to the y. Well, we know 8 is the same thing as 2 times 2 times 2. So 8 to the x is 2 times 2 times 2 to the x. Well, 2 times 2 times 2 is 2 to the 3. And that is raised to the x. And when we do this, we're effectively saying 2 to the 3x. We have to do this step because in order to interact with our denominator of 2y, we need to have the same base, which means we need to have the same big number in this case, which is 2. So we have 2 to the 3x over 2 to the y. When we divide numbers like this, and they are numbers with exponents, and they have the same base, we can then subtract. So we subtract the exponent specifically, my bad. We have 2 to the 3x minus y, where the top one is the front and the bottom one is subtracted from it. Well, we know that 3x minus y is equal to 12, so we can just plug this in directly into the top. So our answer is 2 to the 12. It's much easier and much simpler when you do know the tricks. If you don't know them, you're going to spend a lot of time on this. If ax plus 2 times bx plus 12 is equal to 15x squared plus cx plus 14 for all values of x, and a plus b is equal to 8, what are the 2 possible values for c? Okay. So we know a plus b is equal to 8. We're given ax plus 2 times bx plus 7 is equal to this. So let me think for a second. A times b has to equal 15 because of how these factors will work. So it'll be a times b is equal to 15 to get the x squared. The only 2 numbers that can give us that for a and b are 3 and 5, but a could be 3 and b could be 3, or a could be, why did I do a 6? Oops. So a could be 3 and b could be 5, or b could be 3 and a could be 5. Could go either way. So there's 2 possible options here for c. C is going to be 2 times b plus a times 7. So if b can be 3 or 5 and a can be 3 or 5, we have 2 times 3 plus a times 5, or 5 times 7, or we have 2 times 5 plus 3 times 7. This gives us 6 and this gives us 35, so this is 41. Our only answer that has it is D, but let's make sure that the bottom one actually gives us 31. 2 times 5 is 10, and 3 times 7 is 21. That gives us 31. So our answer is D. Oh, we're already on to the second part. This is going way faster than I expected. That makes sense. I've already done this before. Okay, question 16. If t is greater than 0 and t squared minus 4 is equal to 0, what is the value of t? So we see the t squared minus 4 here. That's the same thing as saying t plus 2 and t minus 2. So t is equal to, subtract 2, positive 2, negative 2, comma 2. But t has to be greater than 0, so negative 2 cannot be an answer. Our answer is only 2, positive 2 that is. A summer camp counselor wants to find a length, x, in feet across a lake as represented in the sketch above. The lengths represented by AB, EB, BD, and CD on this sketch were determined by 1800 feet, 1400 feet, 700 feet, and 800 feet respectively. Segments AC, DE intersect at B, and AEB and CDB have the same measure. What is the value of x? Okay. So AB is 1800 feet. EB is 1400. BD is 700. And CD is 800. AC and DE intersect at B, and AEB is the same angle as CDB. So we know we're working with similar triangles. Let's see. So this side here, BC, is going to be proportional to the same side E is pointing to, AB. However, we want the we want this here, this x, which is going to be proportional to 800. So we have this angle from A, actually. This is one we need to be looking at. This angle from A points to 1400. And then this angle from C points to 700. So it seems like it's 2 times as big. Because if A points to 1400 and C points to 700, we know that this triangle is going to have side lengths that are roughly 2 times bigger. For that reason, we know CD and AE should be proportional, and since AEB is 2 times as big with its side lengths compared to BDC, it should be 1600. According to the system of equations above, what is the value of x? Again, another really simple question. We can do this through substitution, or we can do it through elimination. In this case, I'm going to do it using elimination, because there's a good reason for this. Let me zoom in. This x right here is already all on its own. So all we have to do is subtract this top equation from the bottom one. So that would give us negative x minus y is equal to positive 9. And we're just gonna, well, now we're gonna add it. Now we're not gonna subtract it because I've already made it negative. We're gonna add it to the bottom equation. The x's cancel out. You take away a y from this 2y and you just get normal, or a regular y. And we add a 9, and 9 plus negative 25 should give us negative 16. Now that we have the y, we just plug it into the top equation. If x minus 16 is equal to negative 9, you add the 16 to both sides, and you get that x is equal to positive 7. Very fun question. I love it when systems of equations just have a simple elimination. I hate it when I have to do substitution. Actually, the worst. In a right triangle, one angle measures x, where sine x is equal to 4 over 5. What is the cosine of 90 minus x? If you're like me and you don't know many of the sine and cosine tricks, you just never learned it, we can always draw the triangle. Let's draw a right triangle. The sine of x, or the opposite over hypotenuse, is going to be 4 over 5. So let's say this is x. We're going to make the opposite 4, and we're going to make the hypotenuse 5. What is the cosine of 90 minus x? If this is x, and we know a triangle has 180 degrees, we subtract the 90, because we already know this angle here is 90. So we have 90 degrees. And if we subtract x, we get the other angle in the triangle. Let's call it y. Well, this other angle, its cosine is going to be its adjacent over its hypotenuse. So this cosine is just 4 over 5. Very, very nice answer. Very, very clean. Love it. If a is equal to 5 times the square root of 2, and 2a is equal to the square root of 2x, what is the value of x? Okay, let's just plug in. 2a is equal to 2 times 5 square root of 2, which is equal to 10 square root of 2. And because of this, we know that's also equal to the square root of 2x. So we have 10 times the square root of 2 is equal to the square root of 2x. If we square both sides, we can get rid of that square root, and we get 100 times 2 is equal to 2x, or 200 is equal to x, or 2x, my bad. And we just divide by 2, and we get x is equal to 100. Square roots can be intimidating at first, but if you just work your way through the problem, it can make a lot of sense at the end. Little by little. Awesome. So we just did part 1. That was pretty good time. How long was that? That was about 25 minutes with some intro. Not too bad, not too bad. Alright. Now to the section I did for my speed run. Now that I've gone through and gone over the questions I got wrong, hopefully I can do this way faster than the, I think it was 31 minutes it took me the first time. Doesn't really mean anything because I've already done it once, but at least I can practice for the next speedrun coming up. I will be back in a second after I get a water break. Thank you to everyone that's still watching. All right, let's do this. On to the second part of this practice SAT. John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? Well, at this interval we go from increasing to constant to decreasing, so that's not true. At this interval we go from increasing to decreasing. That looks to be the only one that seems to hold true. And then at the remainder it kind of increases, then goes constant, increases, constant, then decreases. The only one that's an increase, then a decrease, is between the minutes of 40 and 60. That's B. If y is equal to kx, where k is a constant, and y is equal to 24 when x is equal to 6, what is the value of y when x is equal to 5? Okay, so when y is 24, we have k times 6. So we divide both sides by 6 to get k is equal to 4. So the value of y when x is equal to 5 is going to be y is equal to 4 times 5, or 20. In the figure above, lines L and M are parallel and lines S and T are parallel. If the measure of the angle 1 is 35 degrees, what is the measure of angle 2? Well, thanks to parallel lines, we know this angle and angle 1 are the same, and we know this angle, that angle, and angle 1 are the same. So we know that angle 2 is going to be 180 minus angle 1. If the measure of angle 1 is 35, we're going to have 180 minus 35. It'll be about 145, or D. If 16 plus 4x is 10 more than 14, 16 plus 4x is equal to 10 plus 14, 24. What is the value of 8x? Well, subtract both sides by 16. We get 4x is equal to 8, and x is equal to 8 divided by 4, which is going to be 2. So 8x is going to be 8 times 2, which will be 16. Which of the following graphs best shows a strong negative association between D and T? Negative association implies that as one increases, the other decreases. This is just not doing anything. This is a decrease, so this one's looking good. This is an increase. This is a positive association, and this is a little bit of a mess. So I wouldn't say this is strong, but it does seem to be trending downward. D is the only one that is a strong negative association. A hospital stores one type of medicine in 2 decagram containers. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? So if 1 decagram has 10 grams, and there are 1,000 milligrams in 1 gram, we want to multiply this by 1,000 to get the amount of milligrams in 1 decagram. So we have 10,000 milligrams in 1 decagram, but we need 2 decagrams. So this is 2 times 10,000, or 20,000. In hindsight, you could probably look at this again and realize that it's just 1,000 times 10 twice, and A is clearly the wrong answer. That's not even close to B. The only ones it could really be against is C and D, but if you notice it's 10 and 1,000, you're going to be working the 10,000 range. D is the only one that's even close to the correct area. The number of rooftops with solar panel installation in 5 cities is shown in the graph above. If the total number of installations is 27,500, what is an appropriate label for the vertical axis of the graph? So we have a 9 here, a 5 here, a 6 here, a 4 here, and a looks like a 3.5 here. So 9 plus 5 is 14, plus 6 is 20, plus 4 is 24, and the 3.5 is 27. I would say this is in thousands. It wouldn't make sense for it to be tens of thousands because then we'd have 90,000, and it would not make sense for it to be in hundreds because we would have 900, and that just wouldn't be enough. For what value of n is the absolute value of n minus 1 plus 1 equal to 0? If you're not familiar with absolute values, this question can be a little confusing. So let's just try plugging in. For what value of n is n minus 1 absolute value plus 1 equal to 0? If we plug in 1, we get 1 minus 1 absolute value plus 1. Well, That's going to equal 1, because this becomes 0 on the inside. If we plug in 0, we get the absolute value of negative 1 plus 1, which is 2. It seems like we can't get to 0. Let's try graphing this to verify. So we have an n minus 1 within the absolute value. So that's going to shift us to the right by 1. And then we have a plus 1, which means we're going to be up 1. So when x is equal to 1, we are at 1. When x is equal to 0, we are at 2. And then when x is equal to 2, we are also at 2. This is the absolute value. At no point does it ever cross down into the negative or even touch the x-axis. So at no point can any n ever result in this equaling 0. There's another way of showing it, where we could show the absolute value of n minus 1 plus 1. And this can be rewritten as the absolute value of n minus 1. Okay, hold on. I messed it up in the explanation. Let me go back. So let's say we have the absolute value of n minus 1. And what was the way of explaining this? I forget. A little forgetful right now. But there's a way of demonstrating just using the equation and without having to graph that this will never equal 0. Can't seem to remember it now. Oh well. On to the next. The speed of sound in air depends on the air temperature. The formula above shows the relationship between A, the speed of a sound wave, in feet per second, and T, the air temperature, in degrees Fahrenheit. Which of the following expresses the air temperature in terms of the speed of a sound wave? Okay, so we're going to be solving for A. No. Air temperature is T. So we're solving for T. So let's take the original equation. A is equal to 1052 plus 1.08 T. We're going to subtract the 1052 over, and then we're going to divide by 1.08. So it'd be A minus 1052 over 1.08. D is wrong. The 1.08 is on the wrong side. It's a positive A, so C and A, or just C is wrong. So it's between A and B, but since it's A minus 1052, our answer has to be A. At which of the following air temperatures will the speed of sound be closest to 1,000 feet per second? So the speed of the sound wave is A. So when will A be the closest to 1,000? So when is A 1,000? At what air temperature? So we have 1,000 is equal to 1052 plus 1.08 T. We subtract the 1052 over, and that gives us negative 52. Then we divide by 1.08. That gives us, let me pull out my calculator. That gives us about 48, or negative 48 in this case. Which of the following numbers is not a solution of the inequality 3x minus 5 greater than or equal to 4x minus 3? I got this question wrong on my speedrun, unfortunately. And the reason for that is that I just plugged in the wrong numbers, misinterpreted an inequality. It's very important to take your time through these inequality problems, because it's a little harder to think of or imagine what it's going to look like in your head compared to like a regular linear equation. I can't easily understand what this is saying like this. So the easiest thing we can do is to isolate the x to one side. We can do that by subtracting 3x over, and then adding 3 to both sides. So you have negative 2 is greater than or equal to x. Now it is super clear. The ones of these options that don't hold true for this is clearly A. At no point is negative 2 greater than or equal to negative 1. Negative 2 is always less than negative 1. And for the remainder, they all hold true. So A is our answer here. Based on the histogram above of the following, which is the closest to the average number of seeds per apple? So to do that, we need to find how many total seeds are there. In order to do that, we need to find how many total seeds there are, and then we need to divide by the number of apples. So there's 12 apples. So we have 6 here, 20 here. What is this? 6 here again, 14 here, and 27 here. If we add these up, we get 32 plus 14 is 46, plus 27 is, what is it, 63? We divide by 12 and we get 5.25. Let me verify that with a calculator. 6 plus 20 plus 6 plus 14 plus 27. No, I did the math wrong. It was actually around, I think, 73. 20 plus 12 plus 14 plus 27. 73 divided by 12, the number of apples, we get 6, roughly. Always good to check your math. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for approximately 19% of all the survey respondents? 19% of all the survey respondents. So there's 310 in total. So 19% of that would be 0.9 or 0.19 times 310. That is 59. So the closest numbers to that are here and here. The closest one specifically being this one here. So male geometry. Our answer is C. Not too bad, just gotta know what the question is asking. The table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. Of the mean, median, and range of values listed, which will change the most if the 24-inch measurement is removed from the data? Well, we know for median, it's rather safe against outliers because it is just the middle value, and we'll just shift it to the left or the right. So if the middle value is 12 here, it's either, if we're moving this 24, is going to shift it to the left. So it's still going to be 12. No change. The range is 24 minus 8 with the outlier, which is 16. If we were to move the outlier, it'd be 16 minus 8. So now we're down to 8. So that's a pretty big difference. And the range, well, we just did the range. The mean is probably just going to be like 14 with the 24. Let me see. 8 plus 16, 24. Yeah, it's going to be around 14 with the 24, 13 maybe. Removing it is going to decrease it by what, 1 or 2? The answer here is C. You can do the math. I don't think it's worth it. The graph above displays the total cost C in dollars of renting a boat for H hours. Okay, we see the y-intercept is at 5, so we're paying 5 for 0 hours. That's the initial cost. And then after 1 hour, we go up to 8, so this is an increase of 3, I think. And after, from 1 to 2, we go up to 11. So it goes up by 3. What does a C-intercept represent in the graph? Well, C is how much you start with, or how much you need to start paying at time 0. So the initial cost of renting the boat. That is incredibly cheap. I don't think you can find a boat rental like this anywhere in the world for just $5 and then $3 an hour. It costs more to rent a kayak. This must have been like, I don't know, like the 1920s. There's no way. They could at least make this look realistic by starting it off at like 50 and then increasing by 50 per hour. Silly question, silly question. Which of the following represents the relationship between H and C? H is effectively our X here and C is our Y. So if we were to write this in terms of X and Y instead of these silly variables, we would have the increase is 3, so our slope is 3x and has a y-intercept of 5. Now replacing it back with our silly variables, we have C is equal to 3 times H plus 5. Our answer is C. The complete graph of the function f is shown in the xy plane above. For what value of x is the value of f of x at its minimum? Now, the minimum here is the lowest point in the graph, or the lowest y value. It's not where it starts or where it ends, it's just the lowest point on the y. Of course, the lowest x value is going to be this one, but that's not what we're looking for. And in a previous video, or I think a previous short where I had this, some people got that confused. When we look at minimum, we are looking at the y value specifically, and that minimum is going to be here. And we are looking for the value of x at which this happens. So this is -1, this is -2, this is -3. Specifically, this coordinate is -3, comma -2, and since we're looking for the x value, it is -3. In the xy plane, if 0, 0 is a solution to the system of inequalities above, which of the following relationships between a and b must be true? Let's plug in 0, 0. So we have 0 is less than 0 plus a, and 0 is greater than 0 plus b, which is just 0 is less than a, and 0 is greater than b. This means a is positive, it has to be, and b is negative. Because of this, we know a must be true. A positive number is always greater than a negative number, duh. But this intuition here may not come immediately to every person. You just got to ask yourself, what does it mean when you plug in numbers? What do these variables mean? What is this representing? I guess you could also combine these. So you have 0 is less than a, and because 0 is less than a, we have a is greater than 0, and we know 0 is greater than b, which is greater than b, so a is greater than b. That's a way of actually deriving it. A food truck sells salad for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day? Okay, this is a systems of equation problem, and it's probably going to require substitution. I'm feeling sick to my stomach, but I'll move forward anyways. It's $6.50 for a salad, as a expensive salad, and a drink for $2. And they made $836 stealing from people with this super expensive salad. It's funny, a boat is more expensive than a salad in this world. Or the other way around, no, a salad is more expensive than a boat. That's crazy. So 209 salads and drinks were sold in one day, so salad plus drink is equal to 209. So now we isolate the s or the d variable here. We are solving for salads, so let's isolate the d, and we get 209 minus s. We can plug this into the top equation where we have 6.5 s plus 2 times, now we're plugging in for d, 209 minus s is equal to this number. I am not rewriting that with a mouse. So we have 6.5 s plus 418 minus 2s is again equal to the number I'm not rewriting. This becomes 4.5 after combining like terms. And let's subtract the 418 over from the 836. 836 minus 418 okay, 836.5 minus 418, there we go, is 418.5. So we have 4.5 s is equal to 418.5. Divide 418 by 4.5, and we get s is equal to 93. So we sold 93 salads that day. Some very desperate people. Alma bought a laptop computer at a store that gave 20% discount off its original price. The total amount she paid to the cashier was P dollars, including the 8% sales tax on the discounted price. Which of the following represents the original price of the computer in terms of P? Oh my gosh. Okay, so we have she paid P dollars to the cashier, and P is equal to the discounted price times 1.08. The discounted price is 20% of its original price. So D is equal to 0.8 times the original. So let's plug that in. P is equal to 0.8 times original times 1.08. So we want to solve for the original here and get everything else on the other side. So we're going to divide by 0.8 and 1.08 to get that. So it's going to be the original is equal to P, or the price she paid, over 0.8 times 1.08. That looks like it's D. Makes sense. None of the other answers are fairly compelling. A and B are certainly not compelling. It looks like they just added those percents together. C is the only one that would make sense, but we're dividing over, not multiplying. Anyways, the data in the table above were produced by a sleep researcher studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what is the probability that that person belonged to Group Y? So if they at least one, which means 1 to 4 or 5 or more, so we're ignoring this column effectively. So of these two, if a person is chosen at random and they had recalled at least one dream, we're going to do the sum of these two. This is the total group here. And then we're going to find this number here, 11 plus 68, which is 79. And the sum of 39 and 125 is 164. Very cool number. And our answer is C. 200 doesn't make sense because that's not the whole group we're looking at. That is including the nuns. The 100 is just taking Group X or Group Y, so A and B are wrong. But it would make sense if somebody got confused and they saw, oh look, it's 79. I see 79 in Group Y that had 1 or more dreams, and they have a total of 100. But we're looking at the probability that somebody belonged to Group Y based on whether they had 1 or more dreams. And the number of people that had 1 or more dreams is 39 plus 125, not 100. It can be a simple mistake that can get you this question wrong. Okay, here's a super annoying problem that uses really big numbers. This is an enormous time waster on the SAT. It's actually very cruel that they give you this question. Very, very cruel. You're spending a very long time typing in these big numbers on a calculator. Which of the following best approximates the average rate of change in the annual budget for agricultural natural resources from 2008 to 2010? So we're looking from 2008 to 2010 for the agricultural and natural resources. To find that, we're going to take the final, and we're going to subtract the initial, and then we're going to divide by the number of years that have passed, which is 2. So the final is 488,106 divided by, nope, not divided, 488,106 minus 358,708, which is about 129,000, and dividing that by 2 gives us 64,699. Is this in millions? In thousands of dollars. Well, we would just be multiplying this by 1,000 then. So it'd be 64 million. So B is our answer. Of the following, which program's ratio of its 2007 budget to its 2010 budget is closest to the human resources ratio from 2007 to 2010? So this is like a proportional increase and proportional decrease. So let's take a look. The human resources program ratio from 2007 to 2010. Okay, let's see how much it increased by. 5921,379 minus 4051,050. That increased by, not a subtraction, should have been a division. Okay, let me do that again. 5921379 divided by 4051050. That is 1.4 times. So we need to find another one that has that. Let's look at agricultural natural resources. We're looking for 1.46. 4888106 divided by 373904 is 1.3. Our next one to check is education. 3008036 divided by 2164607 is a 1.38. 1.39 actually. Highways and transportation is 1773893 divided by 1468482. It's a 1.27. 207 actually. And public safety is 464233 divided by 263463. That is a 1.76. The closest one to this is education. It just takes way too long to do these problems. It's just way too big. Compared to every other problem on the SAT, you can do most of the other questions between 20 seconds and a minute. But for a problem like this, where you have numbers that are in some of them in the millions, it really is just a waste of time. You're not even doing the actual processing to solve this problem. You're just plugging in numbers to a calculator. And an exam shouldn't be how well can you plug in numbers to a calculator. It should actually make you think. That is my opinion, though. Anyways, which of the following is an equation of a circle in the xy plane with center 0, 4 and a radius with endpoint 4/3, 5? So when we look at center points for circles, we know the equation for a circle is x squared plus y squared is equal, I think it's the radius squared. If it's at 0, 4, that means the x is shifted over by 4. And we can do that with putting x minus 4 on the inside and squaring that. We know this is the case because if you plug in 4, oh, misread that. It's a center of 0, 4. It should be y minus 4, because if you plug in 4 for the y, you're going to get 0. I think I understand that correctly. Anyways, and a radius with 4/3 minus 5, or 4/3, 5. So when it comes to radius, let's see. The distance from this to our center, 0, 4. So if we have a 0, 4 center, and our endpoint is at, what is this, 4, 3? 4/3, 5. I'm trying to think, what is the distance between this? Well, the x distance is 4/3 and the y distance is just 1. How to solve this problem is eluding me right now. At least let's narrow it down. It is a -4, so we know B and D are wrong. So it's between 5/3 and 25/9. Let me draw this out on an actual graph so I can visualize it a little better. 0, 4 is up here. 4/3, 5 would be like right here. So this is the circle roughly. It does form a triangle. So we can find that, or we could just look at the distance between the 2 points. I'm making it much harder than it needs to be. And the whole trick about the SAT is understanding the problem in its simplest terms. So we do x2 minus x1, and that's going to be 4/3. And then we have 5 minus 4, which is 1. And from what I remember, we want to square, no, we want to square root this. So this is, I am definitely doing something wrong here. What is it? What am I getting wrong with the radius? 4 over 3 plus 1, which is... It would make me think 7 over 3. That doesn't look right here. What am I missing? I guess I'll just have to come back to this problem later. I'm not going to get stuck on it here. The equation above expresses the approximate height h in meters of a ball t seconds after it is launched vertically upward from the ground with an initial velocity of 25 meters per second. After approximately how many seconds will the ball hit the ground? So we're going to solve for t here. So we have negative 4.9 t squared plus 25t. It'll hit the ground at 0, at the height 0 at least. So we can pull out a t, factor it out, and we have t times negative 4.9 t, and then we need to divide 25 by 4.9. Well, we're not, no, let's take out, okay, that circle question threw me for a loop. We need to pull out a negative 4.9t, and then we have t minus 25 divided by 4.9, and that's going to be minus 5.1. So t is equal to 0 in this case, because you can plug in 0 and this will become 0, and t is equal to 5.1. So after about 5 seconds, it will hit the ground. Katrina is a botanist studying the production of pears of two types of trees. She noticed that type A trees produce 20% more pears than type B trees did. Based on Katrina's observation, if the type A trees produce 144 pears, how many pears did type B trees produce? Well, 1.2 times A is equal to B, and we know 1.2 times A is equal to 144? No, 1.2 times B is equal to A. There we go, that's the correct equation. So we have 1.2 times B is equal to A, and we know A is equal to 144. So let's divide both sides by 1.2. And that gives us 144 divided by 1.2 is 120. All right. A square field measures 10 meters by 10 meters. 10 students each mark off a randomly selected region of the field. Each region is square and has side lengths of 1 meter, and no two regions overlap. The students count the earthworms contained in the soil to a depth of 5 centimeters beneath the ground surface in each region. The results are shown in the table below. Which of the following is a reasonable approximation of the number of earthworms to a depth of 5 centimeters beneath the ground surface in the entire field? So we're going to be approximating here. If each region is square, it's 1 by 1, no overlap, 10 of the 100 possible locations. So what we can look at is the average between all of these students, and then just multiply it by 100. It looks like our lowest value is 107, and our highest value is 176. The average there seems to be like 140 or 150. And then if we multiply that by 100, it's 150 and add 2 zeros, that's 1,500 times 10, or 15,000. No need to go super deep into the math for it, when we can just kind of reason our way through it. If the systems of inequalities y is greater than or equal to 2x plus 1, and y is greater than 1 over 2x minus 1 is graphed in the xy plane above, which quadrant contains no solutions to the system. This entire page of my SAT speedrun, I got wrong. Every single question on this page. I have a great video on that. If you haven't seen it, check out my channel. I made a very nice animation for this problem. And because I went over these problems again in that video, I will not get them wrong here. So we have y is greater than or equal to 2x plus 1. That's going to have a y-intercept of 1, and it's going to be increasing rather quickly. So it's going to look something like this. And then we have y is greater than 1/2 x plus 1. Let me change the color here. 1/2 x minus 1 actually. So this is 1/2 x minus 1, so the y-intercept at -1. And it's growing rather slowly. And you would think here, oh well, it's in all of them. The solution may be in all of them. But actually, we need to find the overlap. So the y is going to be on this side. That is the correct answer for that side. And for the first equation, we're going to have it on this side. The only place it overlaps is this section, of which none of that is in quadrant 4. In my original answer, I put D, because I only looked at the red one, and I thought it was an OR, which is just wrong. And here we go, this polynomial question. I learned to do this. For a polynomial p of x, the value of p of 3 is -2. Which of the following must be true of p of x? Let's just come up with two random polynomials where p of 3 is equal to -2. The first ones that come to mind are x plus 5, because we plug in, or x minus 5. X minus 5, because if you plug in 3, you do get -2. And the next one is x squared minus 11, because you get 3 times 3 is 9, minus 11 is -2. Sure, x minus 5 is a factor of this one, but x minus 2 and x plus 2 are not. And x minus 5 is certainly not a factor of x squared minus 11. So the only real answer here is D. But let's see why that's the right answer. Let's take x squared minus 11, and let's divide it by x minus 3. If you don't remember polynomial division like this, it's very similar to long addition. So x minus 3, we want to get rid of this x squared, so let's multiply x minus 3 by x, which gives us x squared minus 3x. So on the top we get x. This disappears, and we have the minus 3x. So now we have minus 3x minus 11, and we need to get x minus 3 into this, so let's multiply it by -3. And we get -3x, well actually we just need positive 3. Positive 3x, and what is that? Positive 3 plus 9. Did I do this wrong? Where did I misinterpret this question? Because this should be a positive 9 so that this can cancel out. No, they need to be the same. I was right the first time. It does have to be a -3x, and this becomes a positive 9. We do have to multiply by -3. We need to have the same value in order to be able to get rid of it. This is the same, and we're left with -11 plus 9, which is just -2. We have a remainder of -2. We can't really divide -2 by x minus 3. So it seems that when p of x is divided by x minus 3, it is -2. When it comes to generic problems like this, where it's just giving you any polynomial, at least for me, what I find the easiest is creating them and then seeing if it holds true for any of the answers. I personally can't do polynomial division in my head. Maybe other people can, but I cannot. So it's just easier to plug in sometimes. If this was a free response question, it'd be a different answer. Which of the following is an equivalent form of the equation of the graph shown in the xy plane above, from which the coordinates of vertex A can be identified as constants in the equation? If we're looking at this in the terms of A, we're looking for the vertex form. The vertex form of a quadratic is y is equal to x plus h squared plus v, where h is the horizontal shift and v is the vertical shift. We see that A looks to be at -16. It's not really at -15. So let's say -16. So the vertical shift is down 16. So we know that's that. The only one that has that is D. But let's look a little further. We have x plus h. When it comes to what's on the inside of the square, it's going to do the opposite of what we imagine. So this is shifted to the right by 1. So the h is actually -1. So our answer is D. Indeed it is. Indeed it is. You know, A and B are clearly wrong because that's in the wrong form. And C is wrong just because it doesn't have the square. You could have solved this equation just by knowing what vertex form is and seeing which one of them was actually in a vertex form. But you can also solve it just by looking at the point and seeing what the V and the H are. And we are finally, I think, on the last 2 pages of this math section. Let's get through it. Wyatt can husk at least 12 dozen ears of corn per hour and at most 18 dozen ears of corn per hour. Based on this information, what is a possible amount of time it would take Wyatt to husk 72 dozen ears of corn? On an average hour, he probably does about 15. So let's do 72 divided by 15. It's looking for a range, so 4.8 should be a good answer. The posted weight limit for a covered bridge in Pennsylvania is 6,000 pounds. A delivery truck is carrying X identical boxes, each weighing 14 pounds. If the combined weight of the empty delivery truck and its driver is 4,500 pounds, what is the maximum possible weight of X in the boxes? So we're looking for how many boxes can we fit into 1,500 pounds. So we divide 1,500 divided by 14. I got the 1,500 by subtracting the 4,500 from the 6,000. So we can take about 107 boxes. We can't really have 0.14 of a box. So we have to take the lower of that. So in programming terms, we would call it the floor. I forgot what it was called in math terms. It's called... It's been so long now. I only think in programming terms now. The number of portable media players sold worldwide from 2006 to 2011 is shown in the graph. In 2008, what is the fraction compared to 2011? 2008 has 100, and 2011 has 160. So we do 100 divided by 160. Knock off a 0, we get 10 over 16, which is just 5 over 8. The local television station sells time slots for programs in 30-minute intervals. If the station operates 24 hours per day, every day of the week, what is the total number of 30-minute time slots the station can sell for Tuesday and Wednesday? So we're looking for 2 days, and we're looking for how many time slots can be in those 2 days. There's 24 hours per day, or 48 hours over 2 days. And if we can do 2 30-minute time slots per hour, this is just 96. Seems a little too easy. Whenever I come across an easy problem, I get a little suspicious. A dairy farmer uses a storage silo that is in the shape of the right circular cylinder above. Let me restart that. A dairy farmer uses a storage silo that is in the shape of the right circular cylinder above. If the volume of the silo is 72 pi cubic yards, what is the diameter of the base of the cylinder in yards? Okay, so the volume is 72 pi. We know the volume of a cylinder is a circle times a height. The area of a circle is pi r squared. So we multiply that by h. We see that we can divide both sides by pi. And we know h is equal to 8, so we can divide 72 by 8. That gives us, I think, 9. So r squared is equal to 9, or r is equal to 3. But the diameter is going to be double the radius, so d is equal to 6. Very cool. For what value of x is the function h above undefined? Functions are undefined when their denominator is 0. So what do we have to do to get this to get to 0? So we have x minus 5 squared, which is x squared minus 10x plus 25. We have a 4x minus 5, so we subtract a 4x, or add a 4x, and subtract a 20, and then we add a 4. So we have x squared minus 6x, subtract 20 is 5, add 4 is 9. This is easily factorable. 9's factors are 3, and we have a negative 6, which means we are going to have some negative factors. So it's x minus 3 squared. 3 times 3, negative 3 times negative 3 is 9. Negative 3 plus negative 3 is going to be negative 6. So x is equal to 3. Let's plug it into C. When we plug in 3 for x, on the first part, we get a negative 2 squared, which is 4. When we plug in 3 for the next one, we get 4 times negative 2, which is minus 8, plus 4. Yep, that does take us to 0, and that is where it is undefined, when x is equal to 3. Oh, we're in the last two problems. Finally, we're there. What is the value of x in the expression? Jessica opened a bank account that earns 2% interest compounded annually. Okay, her initial deposit was $100. That's her principal, so we have 100. And she uses the expression 100xt to find the value of the account after 2 years. Okay, the value of x in this is going to be how much the principal, or how much we're going to be compounding every year. If we have an interest rate of 2%, that means we're increasing by 1.02. So our value of x is going to be 1.02. The final question. We've all been waiting for this. Jessica's friend Taishuan found an account that earns 2.5% interest compounded annually. Very bad friend if he does not let her know that there is a better account. Taishuan made an initial deposit of 100 into this account. At the same time, Jessica made a deposit of 100 into her account. After 10 years, how much more money will Taishuan's initial deposit have earned than Jessica's initial deposit? Okay, so we're going to be comparing these after 10 years. We have 100 times 1.02 to the t, and 100 times 1.025, because his is 2.5% to the t. We can easily compare this with, well, we're not going to be doing division. So this is equal to, plug in 10 here, and plug in a 10 here. 1.02 to the 10 is 1.2189. Multiply that by 100. And we get 121.9. 1.025 to the 10 is 1.28. Multiply that by 100 and we get 1.28. So 1.28, or 128, minus 121.9 is $6. It doesn't really mean much in the short term, but I guess if this was with more money in the account, maybe it would have been worth it. Oh, finally, done with this section of the SAT. But I do have some extra problems. If you have any problems you want me to check out, please drop them now that I'm done with the SAT practice. Probably in the next coming days, I'll actually do my next speed run and have that up on the channel maybe next week or the week after. Very exciting. For a little bit of a brain teaser and some fun, I'm going to be factoring some quadratics for a little bit. And then after I'm done factoring these quadratics, I'm going to be doing some polynomial division, because I think these are some of my weakest points. So, let me do some factoring. X minus 7x minus 18. So we look at the factors of 18. That's 9, 2, and then, well, it could be negative 9, 2, or 9, negative 2. What else is there? I think there's 6 and 3. We also have to look at the negative 7, so it has to sum to that. Negative 9 plus 2 is negative 7. So this is the one we're going to go with. So it's going to be an x minus 9 and x plus 2. 2 times negative 9 is negative 18, and negative 9 plus 2 is negative 7. So that is correct. On to question 2. P squared minus 5p minus 14. 14 is 7 times 2, or negative 7 times 2, or it can be negative 2 times 7. Since we have a negative 5, we know it's going to be negative 7 plus 2. And similar to question 1, it's going to be x minus 7, x plus 2. The real trick to quadratics is just knowing what factors you're looking for, and then knowing the middle value, and then which of those factors sum to that value. I find these pretty fun to do because it's fairly simple, as long as you don't have an a value like you see in question 5. Then it gets a little bit more complicated. M squared minus 9m plus 8. 8 has factors of 8 comma 1, or it also has factors of negative 8, negative 1, which looks like what we're going to be using here. So we have x minus 8, x minus 1. negative 8 times negative 1 does equal 8, and negative 8 minus 1 is 9. Very nice. So we have x squared minus 16x plus 63. Okay, so now we have a bigger number, we have more factors to consider. So which of these factors are going to add to negative 16? Because it is positive, we know it's either going to be a positive times a positive or a negative times a negative, but because we have a negative 16, we know it's going to be a negative times a negative, and those have to sum to negative 16. 63 has 21 times 3, and also 7 times 9, so negative 7 minus 9 is equal to, that is equal to negative 16, so we have x minus 7 and x minus 9. For question 5, okay, here we have an a value of 7. This gets a little bit more complicated here. We can still do the same trick, where the factors of negative 20 are going to be negative 5 and 4, negative 4 and 5, negative 10 and 2, negative 2 and 10. I don't think we're going to be looking at 20 and 1, and I don't think there's any other factors. Now, we need to find 7 times one of these, and that should sum to negative 31x. Let's just pre-write this. 7 is prime, so we know it's going to be 7x and then just x. There is no other way of getting 7. So now that we have this, we know that it has to be a positive and a negative, because we have a negative 20. And we know the bigger one is going to be the negative. But which one is the bigger one depends on where the 7 is being multiplied against. So let's see, how can we get a 1 in here? Huh. 7 times 5 is 35, and then we could subtract the 4. I can see that happening. So it's going to be one of these top two. You can forget about these bottom two. So it's going to be 7 times negative 5, and then plus 4. 4 times negative 5 is negative 20. 7 times negative 5 is negative 35. And then 4 times x is negative 31x when you combine that. I think that makes sense. And number 6, very kind, very kind. You just pull out the k and you get 7k plus 9. Phew, it was nice to have an easier one after number 5. Alrighty. Now onto some of the harder questions. Polynomial division. The first thing we can do on this first question is take a 9x out from the top. So we get 45 divided by 9. What is that? 5. So we have 5x squared. 72 divided by 9 is 8. 8x plus 1. And all of this divided by 9x. Take this out, and we're just left with a 5x squared plus 8x plus 1. Not too bad. 40x squared plus 41x minus 21. This one is a little bit more complicated. I have a feeling we can pull out an 8x minus 3 from the top, so let's look at if that's possible. 8x minus 3, is there something else we can multiply this by? I would imagine to be 5x, that's the only way to get 40. And then we'd have to get this over here. This had to be negative 7, or positive 7. Does this hold true? Let's see, negative 3 times 5 is negative 15. So we have a negative 15x. 8 times 7 is 56. I think this is 41x. So we do have an 8x minus 3 on top. So we can divide by 8x minus 3 from the bottom, and we're just left with this 5x plus 7. So the answer is 5x plus 7. A little bit of cheating there just by trying to assume that maybe the top is divisible by 8x minus 3. 12x cubed plus 8x squared minus 40x minus 16. Okay, this is a bit of a longer one. Can we pull out a 2x plus 4 from this? Let's do this the long way. Let's do this the long way. 2x plus 4. 12x cubed plus 8x squared minus 40x minus 16. Okay, how do we get 2x plus 4 to be the same as 12x cubed? We have to multiply the 2x by 6x squared. And that gives us 12x cubed. 4 times 6x squared is 24x. What is that? Squared? Okay. This cancels out when we subtract. This gives us a negative 16x squared minus 40x minus 16. Okay, so we're going to multiply this by negative 8 next, specifically negative 8x. So we have negative 8x squared minus 32x. Or no, this should have been negative 16. That is not what I wanted to do. Okay. So I cannot be doing that. So we add both of these. This gives us a negative 8x minus 16. And I can just clearly see that we're going to be multiplying it by negative 4. We don't really have to look too much into it. So our answer is 6x squared minus 8x minus 4. This way of getting the polynomial division is a little bit more annoying, but you're more likely to get it right instead of guessing by factoring. But then again, you might mess up with some simple math. In my opinion, the less simple math you have to do, the less likely you are to make a mistake. So it's good to know both ways. It's good to know both ways. Okay, 2x plus 5. Huh. Can we pull out a 2x plus 5 from this? I just can't see how I could factor it that easily. It's a little tough. Back to the polynomial division. (14x squared minus 25x minus 25). Okay, so we have an 8x cubed. To get that, we're going to multiply by 4x squared. That'll give us 8x cubed plus 20x squared. Make this negative, make this negative. This cancels out. This gives us negative 6x squared minus 25x. Okay, this next step is going to be minus 3x. So we're going to have a negative 6x squared minus 30x. We're going to add this, cancels out. We get a 5x minus 25. Is that correct? I don't think we can just do that. Did I do some math mistake somewhere? Ah, yes, I see. This shouldn't be 30x here. This should be 15x. Add this, cancels out. This gives us 10x minus 25. So we just add 5 at the end. So it's 4x squared minus 3x plus 5 when you divide this top equation by 2x plus 5. Okay, yet another one. I'm going to see if I can use a different technique here. Let's see. We can try doing factoring by grouping. Let's see if I can remember this. Last time I did this was like 6 years ago. 6x cubed plus 13x squared minus 10x plus 15. How could we do factoring by grouping? We need to be able to find some of these numbers that we can just take an x plus 3 out of. We do have a 13x squared though. I don't see how we could pull anything out of that. Let's give it a try. Let's try grouping the first two and the last two. So in the first two we have x squared 6x plus 13. And then a second 2, we have negative 5. We're trying to get the same values on the inside though, I think. I don't think there's a way to do that with those. Huh. I may just actually have to do polynomial division here. Oh, I made the same mistake. Okay. 6x cubed plus 13x squared minus 10x plus 15. We're going to divide this by x plus 3. So to get this to the 6x cubed, we're going to multiply by 6x squared. So this is 6x cubed plus 18x squared. Subtract, subtract, cancel. This becomes negative 5x squared minus 10x. To get it to this, we need to multiply by negative 5x. Negative 5x squared minus 15x. Turn this into addition. This cancels. This becomes positive 5x plus 15. I don't know how it happened, but it worked out, I guess. There must be a way of factoring this up here that I didn't notice. Because then this is just plus 5. So we have 6x squared minus 5x plus 15 times 5x plus times x plus 3. So you can pull an x plus 3 out of this. I wonder how you would do it with factoring by grouping. Anyways, on to the final problem. 18x cubed plus 21x squared plus 27x over 3x. Well, we can just pull a 3x out of the top and get 9x squared. Nope. Let me do that again. Should be a great YouTube short. 18x cubed plus 21x squared plus 27x over 3x. We can pull out a 3x from the top and get 6x squared plus 7x. Okay, one more time. I'm craving the easy YouTube Shorts content. So here we have 18x. So here we have 18x cubed plus 21x squared plus 27x. Let's factor out of the top 3x. So we have 3x times 6x squared plus 21 divided by 3 is 7x, plus 27 divided by 3 is 9 over 3x. Well, now we can just divide by 3x, and our answer is 6x squared plus 7x plus 9. A very easy polynomial division question. And so, after the long journey today, we have finally reached the end. Unless anyone has any math questions for me to look at. I can't think of anything else to practice or to do for today. Let me think about it for a little bit. I'll take a quick break and then see if maybe there's 1 or 2 problems left. Alright, I found a nice little problem to look at. It involves some squares and circles. I've been having this in mind for a little while. So let me just get this in a better view so I'm not blasting my eyes with bright lights for very long. Okay, let me pull it up. Alright. Let's say you come across a problem and you're given a circle and then there's a square inside of it. And you're trying to find the area of either the square or the area of the circle that's not in the square. So we're looking at A and B specifically, but A and C are fairly identical problems here. See how this looks here. Oh, it's inverted, so it's showing the opposite color. So let me get an orange pen. Should come out as blue. Yes. Okay. So let's say the circle has a radius of, let's just make it, circles have a area of pi r squared. Okay, let me redraw that. I want this to look somewhat appealing. Just redraw all of this. Circles have a radius, and let's make that radius here. We'll just make it 1 for simplicity. So we'll say the radius is 1. The area of this circle then would be pi r squared, which in this case is just pi. But we're not looking for the area of the circle. In A's case, we're looking for the area of this square. We also know that this radius here is also 1. So we know that the diagonal from the square to the center of this half of the diagonal, I guess, is going to be 1. We know the entirety of a square's diagonal. If you were to call a side S, the diagonal is going to be s squared plus s squared is equal to the diagonal squared, or 2 times the side squared is equal to the diagonal squared. We know that the diagonal is 2 because it's just the diameter in this case. So we know 2s squared is equal to, what is this again? This is equal to 2. So the side squared is equal to 1. Oh, actually, no. If d is equal to 2, then d squared is equal to 4. And so 2s squared is equal to 4. S squared is equal to 2. Or s is equal to the square root of 2. So we know this side length is the square root of 2. And now that we know that, we know for A, the area of the square is going to be the side times the side, or s squared. So it's going to be square root of 2 times square root of 2, or just 2. And that's the area of that problem, for at least this A. Now let's look at B. We're going to skip C. We're not going to do C because C is just a repeated 1. It's the same thing as A. Let's look at B. We want to find the area of the circle not in the square. So we know the area of the square is 2, and we know the area of the circle was pi. So since the square is inside the circle, we'll just do the area of the circle minus area of the square. In that case, this is pi minus 2, or it'll be about 3.1, no, not 3 point, it'll be 1.3.141415 ... If you're not great at geometry, and it's been a long time since you've looked at these types of problems, or you don't remember triangles, or you don't remember side lengths, It can be a little difficult to intuitively get to what type of answer you're looking for here, what you need to be working with. But if you know what a radius of a circle is, if you know how that turns into the diameter, and then if you can connect that a radius of a circle and the square inside that circle would have that radius as half of its diagonal, and thus the diameter of the circle would be the diagonal of the square, you can use that to solve for the area of the square, and then you can get that area inside the circle, and then from that, you can get the area of the circle not in the square. You can continue to repeat this, so you have a circle with a square, and inside that square have another circle, and inside that circle have another square, and inside that square have another circle, and you can just keep doing this, repeating the same pattern over and over again. I wouldn't recommend doing this by hand, but it would certainly be fun to do with a program. I'm sure you could programmatically do this in Python or in some other programming language. Regardless, I am all mouth out for today. I think I need some more coffee and maybe a little bit of food. To everybody that did join or is watching this later, thank you. Please consider checking out my recent videos on my SAT speedrun and the 4 questions I got wrong on my SAT. I put a lot of effort into those videos and I would really appreciate it if you checked it out. If you're still here, please subscribe and like. And what's my final thing I gotta say? Nothing else. Have a wonderful day. Best of luck in all your future endeavors.